right, if we want to solve this system of equations with the addition method, the goal is to try to make one of your coefficients of one of your variables the same number but with the opposite signs. When we add these two equations together, that term will cancel out. So in this one, it's not really easy because we're going to end up having to multiply both equations by something. But if I look at the y terms here, okay, I see a -5 and I see a -3. I could turn one of those into a 15 and the other one into a -15 so that when I add them together they cancel out. So that's what I'm going to do. And you know, the number that I chose, the 15, it's really the least common multiple of those numbers, or the least common. We use the same process as we do to find the least common denominator for those numbers. So I'm going to turn one of them into 15 and one of them into -15 by multiplying the whole equation by some number. So I'm going to take the top equation up here and I'm going to multiply it by 3, because 3 times -5 will give me -15. And what that means is that I need to take my second equation and I need to multiply it by -5, because -5 times -3 will be +15. Okay, so I'm going to distribute those numbers to each of those terms and get a new system. So I'd have something like 6x minus 15y equals 12 for my new first equation, right? And distributing that -5, I'd have -35x, okay, plus 15y equals -20. Okay, so we add those two equations together. And the y terms are going to eliminate just like I wanted. That's why I set it up like that. Okay, so adding everything else together over here, 6 and -35 is -29. And 12 and -20 is -8. Okay, we'll solve for x. I'll divide by -29 on both sides. And so my x is going to be negative divided by negative is a positive 829. So we want to try to reduce it, but it's just not going to happen this time. So that's my first part of this answer. Okay, so to get the second part, we're going to need to plug that back into one of our original equations to solve for y. Remember, we're always looking for, when we're solving these systems, we're looking for ordered pairs. We're looking for an x value and a y value. So next I'm going to take that 8/29 and plug it in for x in one of my other equations. Okay, so I plugged it in for x in my equation up there, and now I'm going to solve for y. So I'm going to start by multiplying. Think about 2 like 2/1, straight across the top, straight across the bottom. That'll give me 16/29. Okay, I'm going to subtract the 16/29 from both sides. Okay, so that's like when I change that 4, I need to find common denominators here. Really, you can just put this in your calculator. Do like 4 minus 16 fraction 29 with a 16 fraction 29 in parentheses. I'm going to go and do it by hand, though. I'm going to rewrite this 4 as 4 times 29 is 116. So I can subtract those. That'll give me 100/29 there. Okay. And then finally, I'm going to divide by -5 on both sides to finish up here. Dividing by -5 is the same thing as multiplying by 1/-5, like so. And then that 5 goes into that 100 20 times. So I'll wind up with y equals -20/29. And that, gives me the two pieces I need to put together to get my final ordered pair. My x was 8/29, and my y was -20/29, and that should be my solution to the system. Okay, so we get some fractions. It's a little ugly, a little bit of work here to get through this one, but that's the idea. Okay, so please let me know if you have any other questions or if this is not clear.